Hello and welcome to the Mimosa by Airspan Wi-Fi 6E fixed wireless 802.11ax point-to-multipoint launch. This is Jamie Fink here from the Mimosa team based in Santa Clara. I was the co-founder and CTO of Mimosa and still helping drive this team into doing great products and continuing our push with the fixed wireless revolution here at Mimosa. It's been a great couple of years. I know it's been very trying for all of us during the pandemic. There's been an incredible trend of growth for us due to the high demand for broadband and the dependence on broadband connections that have happened as a result of the pandemic. And I know many of you have really, stressed how important it is to be able to get new technologies and have great supply chain of products. We've really been working extremely hard to maintain those products for the last couple of years. Personally, I've been working on this next-gen technology since we started this company. This is the technology that I came and built this company to introduce, knowing full well that we were going to have new 8x8 technology coming. And I think this is a great time for us as well. After being acquired by Airspan, we really held the team together very nicely. And as many of you probably have heard, we also went public just a couple of months ago. It's a great achievement for the company and a great success. So I think you're going to see great things coming from us. Also, a lot of ability for us to continue to invest in the Mimosa team and these great new products that you're going to hear more about today. We were in Las Vegas last week. It was Papalooza, and introducing the complete new line of the A6 C6 products, which you're going to hear about today. But just take a brief moment to kind of level set where we're going to be at now with these new technologies. So, to date we've been using Wi-Fi 5 based technologies, and they've really had a great place in the arsenal of products and tools in the toolkit for people. But this new Wi-Fi 6E technology that Mimosa has access to, and our ability to engineer and customize this commercially available technology to something really incredible, goes so far beyond what we've ever done before, from a performance, subscriber speeds, as well as reliability perspective. And we're really excited to see these new 8x8 technologies, 7 gigabit access points. You're soon going to be hearing about 3.5 gigabit point-to-point technologies quite soon. It's really kind of unprecedented, I think, the technology changes that we're going to be introducing here, as far as the multiplier of performance that we're going to be seeing in the new technologies here. Before we get started, I wanted to remind everybody also that we had also introduced a new product just about 2 weeks before the launch of the new multipoint platform. A new backhaul in the arsenal. So this is based on some of the same technologies that we've had of the dual channel GPS synchronized products, but is the first one that also introduces our very popular X series antennas. So this new B5X is a 1.5 gigabit product, and it is kind of borrowing from some of the great things that we had in the B5 and the B5C, but expanding up into the 6 gigahertz as well. So now we have 4.9 up to 6.4 gigahertz. And of course, using the exact same antennas that the current C5X products uses. We're going to talk a little bit more about some great new things coming with the antennas later as well. So I think a lot of great new things coming that you're going to hear about, but wanted to make sure you heard about this new product. I think it's our best backhaul yet from a price performance perspective, and also reliability. So great new product in the arsenal, and just wanted to touch on that before we get started on the kickoff. So without any further ado, we're going to talk a lot about the new 6 series products. So the 6 series, not to be confused with just the 6 gigahertz. As many of you know, all of our current arsenal now of products that are in mainstream production now supports 6 gigahertz anyways. So we have a lot of customers that didn't realize that our products supported such a wide band. Many countries obviously haven't allowed 6 gigahertz until now, but we have been doing a lot of 6 gigahertz around the world, and also in countries that are starting to introduce the 6 gigahertz, like the USA, Canada. We're starting to see Brazil, We're starting to see other countries pop up all over the place now that are supporting outdoor 6 gigahertz. And we can already do that today with our current products. We're the only supplier that has consistently always provided a wideband product instead of having multiple products as well. But the 6 series is really also indicative of moving into the Wi-Fi 6E category, which is the latest and greatest technologies, of course, for OFDMA. And we're going to be talking quite a bit about all this new technology. So the 6 series that you're seeing here, this is the A6 product. This is the access point that we launched last week. And it is an incredible integrated design. As you can see here, this is our 8x8 multi-user MIMO chip. As many of you know, we leverage the Quantenna or ON Semiconductor, which is a US-based silicon manufacturer. And this is a very unique chip technology because it is the only 8x8 technology available in the 6 gigahertz today and for quite some time in the market. And it is, quite simply the most powerful Wi-Fi access point chip available on the market today. And more uniquely, we also are the only people on the planet that get access to source code so that we're able to do heavy modifications of the technology. So some really great things here, 7 gigabits of base station capacity, OFDMA technology, which we'll be talking a lot about, new great beamforming technology that is going to enable incredible antenna gains as well as incredible interference management. But I think quite simply put, looking at the spectral efficiency here, a single radio can support up to 60 bits per hertz of efficiency, and when they're used back to back using GPS sync, that's going to get us up to 120 bits per second per hertz. And up until now, I think the highest level in the market has been 20 bits per second per hertz. So this is a huge improvement of spectral efficiency for this industry. We're really proud of this. As you can see, it's a very nice integrated design, a 90-degree design that we'll be talking quite a bit about as we go through here. So what are the things that come in 11AX on Wi-Fi 6E? We have a lot of people that I think know a little bit about this, but I want to touch on kind of the entirety of all of the changes that we get versus what the previous technologies. So as I mentioned, first and foremost, 8x8, that's going to be delivering us up to 4 clients of simultaneous transmission in the downlink direction. And that is also running on much larger new channels. So this new 6 gigahertz band allows us to be able to move into 160 megahertz channels. There are some countries in the world that do support 160 megahertz channels in the 5 gigahertz, but that's more rare based on the regulations that are available. A lot of people will also say, hey, how in gosh names can you sort out using 160 megahertz channels? Is just too much noise to operate such a wide channel. Well, there's also a lot of new techniques in 802.11ax with the new technologies, OFDMA being the largest one. OFDMA introduces much more efficiency, as well as what we call smaller resource units that are going to help us break apart that 160 megahertz so that we don't have to look at it as one big, huge channel. We can look at it as tiny aggregated channels or bonded together channels that can operate independently, which is really cool because it's going to give us a lot of capabilities to be able to deal with noise in the channels for the first time. And we're going to walk through how all of that works and the magic of OFDMA in a little bit. OFDMA, simply put, also lets us have many subscribers simultaneously transmitting back to the access point. So in the upstream direction, we're going to be seeing a huge latency reduction over the prior technology products. So we're expecting to be able to support well over 200 clients very easily with this platform, and we're already doing that in our testing. We also are going to be able to take this product into markets that we haven't been able to do before. So I think this is a great moment for this industry, where I think it's been very challenging in more dense markets to be able to go after wireless technologies, just because of the self-interference, as we have to add many different radios to be able to add more clients. And that's something I think that will be a big trend that we see across the industry. One of the biggest impacts of all of this, not just because of the new band, but because of OFDMA, because of beamforming, and the techniques for using with this antenna, we're seeing just a huge improvement of signal to interference noise ratio, and that means that we're going to be able to operate with much better speeds with noise in the environment, and that's a crucial thing, as we all know, as operators in this band. So in its entirety, it's really tackling so many of the challenges that I know we all have in the 5 gigahertz every day. The technologies are being introduced, of course, both into the 5 and the 6 gigahertz. So this isn't just a 6 gigahertz product. This product goes across the entire band, which is fantastic. It's going to be very unique that we're able to do the entire band as well. Okay, so let's start talking about some of these technologies to make it a little simpler to understand. So let's first talk about the downlink 7 gigabits and multi-user MIMO. So essentially, we're going to be able to beamform 4 different sets of patterns simultaneously. So that means the 8-stream MIMO gets split into 2 streams per client. And of course, those are highly directional beams within this 90-degree antenna. So what happens then is, as we see traffic coming in the access point based on QoS settings and things like that, we'll prioritize clients that are spatially diverse and that we can beamform independently at the same time. And that's going to allow us, obviously, to be able to transmit up to 1.75 gigabits to a 2-stream client, which is the C6X device that we'll talk about soon. That is assuming a couple of things. That's assuming 160 megahertz channel. This is also assuming a 1024 QAM signal strength, and we're very big believers with the new band as well, and our interference mitigation techniques that we're going to be able to achieve quite a bit of 1024 QAM out in the field from what we're seeing right now. But obviously, if you're running 80 megahertz channels and things like that, you're going to be running more like 900 megabits downstream, a little less than that. As you go down to a 40 megahertz channel, that's more like 450. So, I think this is a great improvement over what we've been able to do in the past, per client, as well as the capacity at the access point. So I think one of the most important aspect of 11AX is the move from OFDM to OFDMA. And there's a lot of things that are impacted in this change. Obviously, it's very, very different at the access point, because previously we were running in OFDM a single user MIMO technique. So only one client could request bandwidth at a moment in time for the upstream channel. So if you're doing TDMA scheduling, it's quite inefficient to have to ask only one client to transmit at a time. And it means you're doing a lot more of the work of scheduling those clients as they have upstream requests. And of course, as we're doing things like Zoom now with a lot of upstream work, this means that there's a lot more demand for the upstream. So OFDMA lets us split up the channel in resource units. And resource units are made up of base 2 megahertz chunks. Typically, you're going to be taking a channel and dividing it by 4. For the highest efficiency of number of clients that you can get to achieve the lowest latency. So in this scenario that I'm showing here, each user would be getting about 40 megahertz of a 160 megahertz channel. Of course, if it was a 20 megahertz channel, it can go down to lower numbers as well per user, but it doesn't have to be 160, but we're just using that as the example here. So each client then gets a portion of the upstream, which would be 1.75 gigabits in this scenario. So we're focusing on this mode initially. The chip technology also can support multi-user in the upstream, but initially our focus here is to get the highest performance latency. So the best latency and the best scale, so the more users that we can predictably have reliably at low latency is really the goal that we're going after. So the upstream aggregate in this mode is 1.75 gigabits. So great approach for lowering latency here. And I think we're seeing about 4 to 5x lower latency in practical real world than we were with the previous generation. Okay, so moving more into the noise impacts. So obviously beamforming is a big one. The ability to scan the scope of the 90-degree sector and looking for directional noise. So this is noise that we're able to spatially detect that is coming fairly consistently at the antenna. We're able to identify those locations and drop spatial nulls with that antenna matrix. So having it 8x8 allows us to be much more refined as to isolating that directional noise, and allows us to kind of essentially move the beams that we are receiving from clients at any moment in time to avoid directional noise that's in the channel. So you're going to hear me talking a lot about this in-channel and out-of-channel adjacent band interference. This is some of the first approaches that are being used in the industry to tackle in-band noise. The second technique for in-band noise is these new OFDMA resource units. So today, in the legacy technology, we have 80 megahertz channels, and those 80 megahertz channels are essentially blocked if they have any noise in the band. The whole channel is the resource unit. Now with OFDMA in the 160 megahertz channels, when we see noise, we can essentially ignore the resource units that are impacted by that noise and null those particular resource units. And this is the key to being able to take wide channels, even if there may be some noise in a portion of that channel, and reduce the impact of that noise. And that's something that I think we've been waiting for a long time to be able to do, because this capability to have wide channels is so incredible to be able to impact speed and capacity of the radio. And there's just so many rip channels that are just slightly impacted that would cause most of a larger channel to be effectively not usable in past techniques. And this is going to open up those channels, I think, for a lot more broad use, essentially. And of course, one of the key things that we always focus on is antenna designs on the CPE side. So we all know that noise on the client side typically comes from Wi-Fi devices. So when you're in neighborhoods and people are running Wi-Fi in the same channels. Now, a couple things here. This is showing the pattern of our X25 antenna. So we already have about a 10 dB better isolation than the next best subscriber unit in the industry of a similar gain. And you can see that from the patterns here. And what that means, of course, is we're isolating out more noise. But of course, as we move into the 6 gigahertz as well, there's going to be even less noise, because the power levels that are allowed indoor for consumer Wi-Fi are considerably lower. They're really almost a fraction of what the power levels used to be for indoor Wi-Fi. So we're very confident that this 6 gigahertz band can be more relegated outdoors for ISP and carrier applications, not consumer Wi-Fi so much, and that we're going to be able to maintain a better noise floor and better isolation between indoor and outdoor. So all of these things combined, I think, are what we're seeing as leading to, roughly speaking, about a 20 dB signal noise ratio of what we used to see with the previous technology. And that's just an incredible accomplishment for us to be able to take into these new products. So let's talk a little bit more about the impact of OFDMA. So in the past with TDMA and OFDM, obviously we had to fill up time slots based on need, and those time slots were a specific size. In the past we were doing 8 millisecond time slots. And in most scenarios, a user just simply couldn't fill up the time slot effectively. They just didn't have that much upstream enough to handle the capacity of the phi rate that was available. There was a lot of unused space. With OFDMA, I'm gonna schedule multiple users into that time slot onto different frequencies, and what that is going to do is effectively take those 4 users and collapse them into a single time slot, so to speak. So this is going to give us a lot more efficiency to use as we take those underutilized portions of the time slots. So that is not just a latency improvement, of course, but it's also a capacity improvement. So OFDMA is really the secret of the success of this product. That it's going to allow us to schedule more efficiently the users, reduce the latency, get much better capacity, and that means also much higher subscriber count on the system. So I think that this is, in the past, people have been taking 30 to 40 maximum users per radio. I mean, we've seen, of course, systems that could go higher than that, but the latencies start to go up considerably. And the only solutions to that were using narrower antennas and smaller channels. And what that means is, as an operator, you've been carefully crafting your network, getting narrower and narrower and narrower to make sure that you're maintaining a speed for your customer without as much interference. And it's much harder to organize all of these radios on many more antennas and smaller channels now. So with OFDMA, this is going to let us go to considerably broader antennas with higher capacity. And this is, I think, a big deal in the stability management and handling of trying to deal with scale on a network. And we're already seeing some of our larger users, they're cheering for this feature because it's been incredibly frustrating to keep adding radio after radio after radio and using different channels and reducing the channel size. It's been slowing down their subscribers as they've been increasing in scale. And I think that that's a key thing that we have to have as we move into the new products. Okay, so let's look at all the specs here. This is the core specs of the A6. I think the key things here are it is integrated in 90 degrees. We'll talk a little bit more about that in just a moment. And the band goes from 5.15 up to 6.425. So we've already seen some of the other first specs of fixed wireless systems with the 11AX technologies. And it's very difficult to get a wideband antenna. So we're really proud of the fact that we've been able to design a high performance antenna across the board that gives us high performance both in the 5 and in the 6 gigahertz. This is the first generation of this that supports the lower portion of the 6 gigahertz band. We are still working on upper portion versions of this product, the higher portions of the band, but as this is all very new technology, this is now all just coming to market from the chip manufacturers. So yes, we will be having products that go up to the 7 gigahertz range, but at this time, we're supporting up to 6.425 in the A6. So the thing that really is most impressive to me here is the antenna gain. So we are running 24 dBi on this antenna. And while it looks really big in this picture here, the antenna is really compact. It is incredible efficiency, and it's by far the highest antenna gain I've ever seen on a 90-degree product. So achieving 24 dBi, of course, comes from the 8x8 MIMO. And I think it's a great testament to the technology that we're able to get smaller in size, but much higher in gain. And one of the key differentiator we have here is power levels. So we're able to support up to 29 dBm of transmit power on the A6. A lot of people look at the regulations in the 6 gigahertz and they say, hey, I heard that the power levels are going down in the 6 gigahertz. Well, that's not quite accurate. They're on the access point, they're staying the same. It's 36 dBm. So, you probably don't need the power in that scenario, but in 5 gigahertz bands, you do want the power. And this product supports the entire band. And you don't always know when you're going to be deploying in the 5 gigahertz versus the 6 gigahertz. So we believe that the high power is absolutely necessary for products like these. I think low power products being used outdoors are really a waste of the technology and very expensive cost for not introducing the higher power capabilities into the band. And again, I mean, having one product that does both of these is a real convenience factor for all of you. So let's take a look at the antenna design a little bit more in detail. So it's roughly speaking just under 300 millimeters and about 483 millimeters tall. So it's about a foot wide and about 20 inches tall, as you can see here, 19 inches tall. How does that stack up? So many of you are probably familiar with the other 14 by 14 product that was in the market. Now, I should remind you that that product I think is a 1 gigabit capacity product, and I think is a roughly 80 watts of power consumption. Well, you can see the size difference here and how much smaller this is. So that one is 14 dBi. This is 24 dBi that we're delivering here. And we're also doing it under 40 watts. So quite power efficient, extremely size efficient. And of course, this supports the entirety of the band. So we're really proud of what we've been able to achieve in size and efficiency here of the product. So looking at the connectivity options, there's a lot of cool new things that we're doing here that I think you're really going to enjoy. First and foremost, we're introducing for the first time a dedicated 48-volt power interface. So much easier for those of you that are trying to maintain high reliability and avoid the impacts of lightning strikes. Direct 48-volt is obviously key in assisting in maintaining that high carrier grade level of hardware availability. Now, also, again, focusing on hardware reliability, there's a lot of new PoE technologies. There's 2.5 gigabit, 5 gigabit, 10 gigabit copper technologies, but frankly, they're very limited in their range, and they're also much more sensitive already. We know that there's real challenges with maintaining high availability of Ethernet on PoE. So, you of course have the 48-volt dedicated interface, but we wanted to deliver the highest reliability PoE plus that we could. This is both active and passive, so we can support the standard 8.2.3 AT plus, etc. PoE plus, as well as the passive ones that come from many of the popular WISP switches that are out there. But of course, this is a high performance product. So high performance product requires fiber. So we are introducing something quite unique here where we have 2 fiber interfaces on SFP+. So these are fiber only interfaces. These obviously are much better for reliability, of course, but also of guaranteed speed, so that we're always going to be at 10 gigabit. And one of the big challenges as we're moving up in performance, of course, is the cost of switching. So as you put these at a site and now have to put in 10 gigabit switches for multiple radios, that can get quite expensive. And we looked at this problem and talked to a lot of our customers. And what we decided was the best thing for all of us was to provide a built-in switch that allows us to daisy chain the access points and to the backhauls. So if I'm running a small site and I don't really want to have to put a switch out there and do an outdoor hardened 10 gigabit switch, you don't have to. You can connect up one fiber interface to a backhaul and then daisy chain between the radios on these 2 fiber SFP plus ports. So I think that was, when I was out in Vegas last week, that was such a popular feature. I think a lot of people, of course, have been looking for higher speed fiber interfaces, but I don't think anybody was expecting the switching capability, because that is a real problem at a lot of these smaller sites. So I think that this is going to be a very useful feature for many of you that are looking to start deploying these smaller sites, especially in the 6 gigahertz. One other nice thing, we've also gone a little wider on our glands. So for those of you with fat fingers, so to speak, getting up into those glands and releasing cables and things like that, made that a little bit easier by moving up to wider M30 glands, which is quite nice as well. Okay, so let's talk about the CPE. Most of you are probably familiar with our C5X as a CPE in the 5 gigahertz. And we have IP67 options starting to come out, the new C6X, and of course the new B5X. All of these are what I call the X series products and support all of the X series antennas. So these are the exact same antennas that we've been using for the C5X. They will all be supported on the new radios. So we're using these common across the platform, so you can buy them for any of these, of course, now. So today we have up to 25 dBi, and of course, built into the radio is an 8 dBi with a small radome. So the twist-on interfaces take you from 8 dBi up to 25 today. So some great news on this front also is that, just as a teaser, we will be introducing high gain versions of these antennas in early 2022 as well. So you will start to see this series of antennas expanding, making it, again, incredibly easy. But most importantly, these antennas are custom designed. We built these antennas ourselves because we felt that there wasn't a good wideband antenna that supported up to the 6 gigahertz. Most parabolic antennas have a moding out problem, as it's called, right at around 5.9 gigahertz. And we were able to redesign that using these Cassegrain and horn style antennas to make sure that we can build antennas that work across the band with extremely high isolation. So we're going to continue that success and push that up into higher antenna gains in the 30 and 34, 35 range. So I think you're going to really enjoy that, and just to continue to show our commitment to this platform. But most importantly, the cost points of these antennas are incredibly good for keeping value for your customers and making it easier to deploy. So any one of the radios, and you can stock these antennas across those directional radios now. Okay, so let's talk about the C6X, which is the primary client for the 11AX OFDMA A6 product. So the C6X really shares much of course, of the specs of the base A6. The big difference here is it's a two-stream client. So as I was mentioning earlier, with an 8x8 access point, 4 two-stream clients is kind of the way that we run the beamforming and the multi-user MIMO and the OFDMA. So these, of course, support the 160 megahertz channels. We are introducing initially a 1 gigabit PoE plus, so that's a 2 gigabit aggregate interface, of course, but we're still focusing on PoE plus here for cost reasons. So we want to keep this as low cost as possible. So we keep Ethernet, and of course, we're focused on the low cost antennas. This is, again, focusing mostly on antenna techniques here for the isolation, and of course, the access point is doing much of the noise fighting for the system at the base station location. So lots of cool stuff coming down the pipe here, and as mentioned, those new antenna gains are coming in 2022. So we'll definitely be able to use these in most scenarios where you would have had to use a much more expensive third-party connectorized antenna. So I think this is great news for all. We are starting this product out, of course, as you can see, as IP67. So another, good nod here as to the reliability of the products that we're building here, and building them as a great value as well, as you'll hear in just a moment. Okay, so let's touch a little bit on the management side of this. How are you going to manage these technologies? We've been known in the past at Mimosa for our cloud technology predominantly, but we have a lot of our customers that have been asking for putting their management in country. They want their data security, privacy of their data on site, or at least in a cloud in their own country, for a mixture of privacy and legal reasons. But also you may want to dedicate your own management resources and servers to your own cloud or your own local devices. And that comes by virtue of the Mimosa Management Platform, or MMP as we call it. We introduced this, I think, in June, July timeframe initially. And the MMP is taking our cloud technology and expanding it considerably in features, as well as the ability for you to host it yourself. So MMP is basically a standalone management platform that takes our cloud technology and puts it effectively on steroids, and a ton of new features that's going to allow you to scale this into a fixed wireless network for point-to-point or point-to-multipoint for that matter. We will still keep the cloud for those of you that want to use the lightweight feature set, but if you want things like all the APIs and a lot of the new configuration capabilities that are coming in the MMP is going to be very interesting, I think, for you. So to start off with, the MMP is free for the first 5,000 devices, and the basic features that we essentially have today, most of the features in the cloud are in the free package. So we basically, if you're familiar with some of the cloud, you'll be familiar with the free capabilities that come predominantly in the MMP. We then move into a series of licenses for pro features, for more enterprise integration, a lot of the device configuration features in the basic package, license A, and then when you want to start doing a much larger network, then you're going to want to be able to go to extended devices beyond 5,000 devices, and also multiple servers. So those are licenses that you can purchase through our distribution channel. These get redeemed as a voucher in our cloud, so it's a very easy process. to pick up your cloud, your key in our cloud. You don't have to be connected to the cloud, so to speak, as a system. You can request an offline key and things like that, but it's a very easy process to be able to pick up the keys. But the 6 series, of course, is going to be the most featured version of product that we have in the MMP. There's an entirely new API that we're taking advantage of in managing the devices, which is great. Again, further optimizing efficiency of device data monitoring, etc. So again, I think a lot of great work that we've been doing in the last couple of years here that you guys are going to be able to take advantage of.